Hi statisticians, today's lesson is on bias and non-random sampling. Let's get started. To help attract applicants, colleges spend a lot of money renovating and maintaining their pretty campuses, sending out pretty mailers to prospective students, and showing off their pretty data. Yes, colleges go through great lengths to share data on their generous financial aid awards, impressive graduate salaries, high job placement rates, and stellar campus life satisfaction survey results, all of which can show prospective students how happy they'd be if they attended their university. But all of that raises the question, does this data always point to the most accurate portrait of life on campus? So that brings us to our key question for today. Can data about colleges be misleading? With that question in mind, let's move into our notes. We're going to cover 3 topics today, starting with bias. Bias is a flaw in a sampling or measurement procedure that leads to systematically over or underestimating a parameter value. It's important to pay attention to bias because it can lead to unreliable or even wrong conclusions. The key to eliminating bias is to sample randomly from the whole population of interest. To dive a bit more into what bias is and how to avoid it, we're going to describe several types of bias, starting with sampling bias. Sampling bias is bias that comes from selecting a sample that is not representative of the population of interest. It might happen out of convenience, or to keep costs down, or any number of reasons. We're going to look at 3 types of sampling bias as we go through this statistics course. The first is undercoverage bias. To explore undercoverage bias, let's take a look at some pretty data from Palo Alto College, a community college in San Antonio, Texas. In 2021, a student was applying to Palo Alto College, and he found this statement on the school's website. 89.3% of their graduates found full-time work or enrolled in their next level of schooling. Keep in mind, this is a community college, so both of these outcomes, finding work or transferring to a 4-year university, can be considered good outcomes after graduation. So after seeing this student said, "That's great, I'm going to apply." However, I had a different reaction. Specifically, I had a suspicion that the 89.3% statistic might be misleading. Take a moment to pause the video and think about how this statement might be misleading. Okay, let's discuss. So, note that the statement says 89.3% of graduates have good outcomes, not 89.3% of all students who enrolled in the school. 89.3% of graduates. This raises the question, how many students actually graduated? Well, by law, graduation rate data is reported to the government and is publicly accessible online. And if you look it up, it turns out that among students who enrolled in Palo Alto College in 2020, only about 48% either graduated or transferred out. So although many of these students had good outcomes, among the other 52% that didn't graduate, we don't really know what happened to them. Ultimately, the majority of the students that enrolled in the first place, 52%, did not graduate. These students may have had a tougher time finding jobs. So what does that say about the pretty 89.3% that we saw earlier? That's right, it's BS, and we know what that means. Bad statistics, of course. And this is an example of undercoverage bias, when part of the population is excluded or is less likely to be selected for the sample. In this case, non-graduates were excluded from the calculations of job placement rates. So, if you are asked to describe a potential flaw in a sampling design like this one, you're going to make sure you need to cover a few things. First, identify the population of interest and the sample. Then, identify the observational units that were excluded from the sample and how they might differ from those that were included in the sample. And finally, explain how this exclusion leads to either an overestimate or an underestimate of the parameter. So, taking this example from earlier that we were asked to look at, let's see how this statement might be misleading. First, we're going to identify the population of interest, which is all students that enrolled in the college. And then we're going to identify the sample. In this case, it's just the students who graduated. That means that the sample excluded non-graduates, and they might have struggled to find jobs. And this exclusion would likely lead to an overestimate of the true job placement rate, since the graduates may have had an easier time finding jobs than the non-graduates. Putting it all together, we would write something like this. Prospective students may be interested in the job placement rate of all Palo Alto College students. That's the population of interest. However, the sample only includes graduates. That's the sample. This excludes non-graduates who may have had a harder time finding jobs. That's the exclusion statement. So 89.3% is likely an overestimate of the true job placement rates among all students. And that's the final over-under claim. Now, it's worth noting that even if we really just were interested in job placement rates among only graduates, that these sort of figures can still sometimes be misleading. And that's because of the type of sampling bias called non-response bias. To see an example of non-response bias in action, let's look at another set of pre-college data, this time from Rogers State University in Oklahoma. In a report studying graduates between 2017 and 2019, Rogers State found that about 75% of their graduates are pursuing another degree or had found full-time employment by their final semester. Again, it's impressive to look at first glance, but what do we need to look at further? So we're going to look at this time how they collected their data. It turns out they collected it with surveys, and the same report shows that the response rate was about 20%. So 1 in 5 graduates responded. That's a pretty low response rate and a warning sign of bad statistics. This is a type of bias called non-response bias. Non-response bias happens when individuals who do not respond to surveys are somehow different from those who do respond. For example, non-responders on alumni surveys may differ substantially from responders, especially when it comes to questions about finding jobs. To explain more, we'll look at the same process as before. We'll be asked to identify the potential flaw in the university's sampling method. We'll first identify the population of interest, all alumni or all graduates. Then we'll identify the sample of who was actually measured, and that in this case, that would be the people that actually responded to the survey. We'll look at who that excludes, and in this case, that's the non-responders. Those people might feel differently. Maybe they didn't respond because they are embarrassed about not having a job. And then finally, we'll look at whether that's an over or underestimate. So we could argue that the 75% claim is likely an overestimate of the true job placement rate among all graduates. Putting it all together, we'd have something that looks like this. We are interested in the job placement rate of all alumni of Rogers State. That's the population. However, the sample only includes alumni who responded to the survey. That's the sample. This excludes non-responders who may not have a job and feel embarrassed to report it. That's the exclusion statement. So 75% is likely an overestimate of the true job placement rate among all alumni, and that's our final over-under claim. The final type of sampling bias that we'd like to look at today is voluntary response bias. Voluntary response bias occurs when a sample consists entirely of volunteers who might differ from the general population. Imagine that we're looking at a case like this. The university official believes that students at their school, which provides free gym access, has especially good cardiovascular health among students. To test this idea, the official recruits student volunteers to run a mile and then measure their average heart rate. We're being asked to describe a potential flaw in this process. Well, we might want to point out the following. namely that the official is interested in the average heart rate among all students at the university. However, their sample only includes students who volunteer to run a mile on their own accord. This excludes students who don't volunteer, who may have higher heart rates because it makes running more difficult for them. Therefore, they might not actually want to volunteer to run. And I don't blame them. Personally, I would not want to volunteer to run a mile. But I digress. So you can see that we're pointing at the population of interest, all students at the university, and we're pointing at the sample, the students who would want to volunteer to run a mile on their own accord. And we name those who are excluded, the non-volunteers, who may tend to have higher heart rates. And finally, we've made our over-under claim that the official will likely underestimate the true average heart rate among the population of all college students. Now that we've gone through several types of sampling bias, let's discuss a slightly different flavor of bias called response bias. Response bias is a category of bias that arises from responses to a survey being taken. Usually it is when the survey results are different than the true values that should show up. And it's a result of different types. So we're going to study two main types in this class. The first is question wording bias. Question wording bias occurs when the survey questions are confusing or leading. Here's an example. Which do you prefer? Diners, dives, and drive-ins, hosted by the incredibly talented, funny, ineffable Mayor of Flavortown, Guy Fieri, or Iron Chef, hosted by the boring Alton Brown. You can see how this question might lead to an overestimate in support of diners, drive-ins, and dives, or an underestimate for Iron Chef. Another type of response bias is self-reporting bias, which happens when individuals inaccurately report their own traits. For example, if I were asked how much weight I can bench press, I might respond, 350 pounds. Of course, that's because I am being modest and don't want to brag too much about my own traits. Just kidding. I can really only lift the bar, which is about 45 pounds, and that's probably more common, where people will alter their responses to make themselves look impressive. So, to summarize, one way that we can have bias is through the way that people are selected. This category is known as sampling bias, and there are three subtypes, each of which is shown here, under coverage, non-response, and voluntary response. Bias can also arise in how the data is measured, specifically when it comes to surveys. And we are mainly looking at questioning, the way the question is worded, and in self-reporting. So those things bring us to our discussion question for the day. Imagine that a university official wants to gather student opinions about campus housing. It's a really big campus, so sampling the whole campus will be time-consuming. They've got limited resources, and they've got two options for how to perform the survey. Option one, they can do a random sample of 25 students across the entire campus, or they can get 500 students from one dorm. Our discussion question is, which option should the official choose and why? Take a moment to jot down your initial thoughts, and we'll discuss this question further in class. That's it for today, statisticians. We'll see you next time.